The most brutal line in all of physics, and nobody talks about it at dinner. Everything that exists is in the process of ceasing to exist. Stars, galaxies, black holes, civilizations, consciousness itself. The universe is not building towards something, it is unwinding, slowly, magnificently, and without the slightest concern for who's watching. And right in the middle of all that unwinding, right in this absurdly narrow slice of cosmic time, life appeared and had the nerve to ask why. Not just survive, not just replicate, but wonder, question, philosophize. Do science at 2 a.m. with cold coffee and a chalkboard full of beautiful mistakes. That defiance, that tiny biological rebellion against meaninglessness might be the single most extraordinary thing that has ever happened in this universe. Here's why it matters more than anything you've been told. There is a law in physics so fundamental, so unbreakable, so woven into reality, that nothing has ever escaped it. Not once. It is called the second law of thermodynamics. In plain language it says this: things fall apart. Always. A hot cup of coffee cools down. It never heats back up on its own. A shattered glass does not reassemble itself from the floor. Smoke rises and spreads. It does not gather back into a tidy column. These are not accidents. These are the universe obeying a rule. It has never broken in 14 billion years. Scientists measure this tendency with a concept called entropy. Think of entropy as disorder. When your room is clean, entropy is low. When it looks like a storm passed through, entropy is high. The second law says entropy always increases, always moves from order to disorder, from concentrated to spread out, from structured to scattered. The universe, taken as a whole, is always moving in one direction, toward maximum disorder, toward a state where every particle is spread so evenly across infinite dark that nothing interesting can ever happen again. Physicists call that final state the heat death of the universe. It is not dramatic. No explosion, no fire, just stillness. Perfect, featureless, eternal stillness, where temperature everywhere is the same, no energy flows anywhere, nothing moves, nothing changes, nothing thinks, just particles, evenly distributed, in infinite cold silence. That is where everything is going. That is the destination written into the mathematics of reality. Nothing we build, nothing we discover, will change that final address. Now sit with that, because here is what makes it strange. The second law tells us the universe always moves toward disorder. But look around you. Galaxies arranged in sweeping spiral arms. Planets with liquid water and magnetic fields, forests, nervous systems. The human brain, 3 pounds of tissue running on 20 watts, roughly a dim light bulb, generating mathematics, music, grief, and the ability to wonder about its own existence. None of this looks like disorder. All of it looks like breathtaking, improbable complexity. So which is it? Is the universe falling apart or building up? The answer is both. And understanding how both can be true simultaneously is the key to everything that follows. Think of it like a river. A river flows downhill. That is its destination. That is the law. But on the way downhill, it carves canyons, creates waterfalls, supports entire ecosystems along its banks. The river is always moving toward its destination, the flat, still ocean, but the journey creates structure and complexity that could not exist without the flow. Life is one of those structures. Consciousness is one of those structures. We are the river, carving its canyon on the way to the sea. The sea is still coming, but the canyon is real, and it is extraordinary. Richard Feynman understood this more deeply than almost anyone. Feynman won the Nobel Prize, but that description understates what he actually was. He was a man who found genuine, almost childlike joy in understanding things. Not performing understanding, not collecting credentials, actually understanding. He said the pleasure of finding things out was the greatest pleasure he knew, and what he kept returning to, what he kept turning over like a stone with something remarkable underneath, was why a universe governed by laws that push everything toward disorder managed to produce, even temporarily, something as improbable as a mind that asks questions about it. That question has no clean answer. Feynman knew that. He was suspicious of clean answers. He thought the universe was stranger than our intuitions allow, and the question of why anything complex exists in a universe that prefers simplicity is one of those places where the strangeness runs very deep. Here is one piece of the answer. Think about the sun differently than you probably have before. Most people think of the sun as a source of energy. That is true, but incomplete. What the sun actually provides is a difference. A gap. The sun is very hot. Space is very cold. Life on Earth sits in the middle of that gap and exploits the flow of energy from hot to cold, the same way a water wheel exploits the flow of water from high to low. Energy flows through living systems, and on the way through it creates and maintains structure. A plant captures sunlight, builds complex molecules, releases lower quality heat back into space. The plant is not violating the second law. Entropy is still increasing overall, but the plant is using the flow to build order locally, temporarily, the way a whirlpool uses a river's current to maintain its spinning structure, even while the water keeps moving downstream. You are a whirlpool, a temporary, self-maintaining pattern in a flow of energy moving from the sun toward cold space. You are not a thing so much as a process. The atoms that make up your body right now were not part of you 7 years ago. What makes you you is not the specific atoms, but the pattern, the organization, the structure that keeps renewing itself by pulling energy from food, which came from sunlight, which came from the sun burning itself out slowly in the sky. When that flow stops, when you die, when the sun eventually expands, when the stars burn out one by one, the pattern dissolves, the whirlpool stops spinning, the entropy account is settled. But here is what Feynman kept coming back to. The whirlpool does not know it is a whirlpool. The river does not know it is flowing. The coffee does not know it is cooling. But somewhere in the long history of energy flowing on this particular planet, the pattern became aware of itself. The structure became curious about the flow that created it. The process began asking questions about the process. That is not a small thing. That is possibly the most singular event in the history of the universe. We do not know precisely how it happened. That is the honest answer. The precise mechanism by which chemistry became experience, by which neurons firing in the dark of a skull became the felt sense of existing, remains one of the deepest unsolved problems in all of science. Philosophers call it the hard problem of consciousness. Hard not in the sense of difficult, though it is that too. Hard in the sense of fundamental. You can explain everything about how the brain processes information and still not explain why there is something it feels like to be the brain doing that processing. Why the lights are on. Why anyone is home. Feynman held that question open. He treated not knowing as an invitation rather than a failure. He said it is much more interesting to live not knowing than to have answers that might be wrong. That sounds like making peace with ignorance. It is actually something more radical. It is a claim that the open question is itself valuable, that sitting with genuine uncertainty, really sitting with it without flinching, is a form of intellectual honesty that most people never manage. Most people manage it by not looking directly at the question at all. What Feynman saw, when he looked directly, was that the universe did not have to be this way. This needs a moment before you move past it. The laws of physics are not logically necessary. There is no contradiction in imagining a universe where the laws are different, a universe where entropy does not increase, a universe where complexity does not emerge, a universe that is just radiation and particles, featureless forever. Our universe is not that universe. Our universe has laws that, for reasons we do not fully understand, allow pockets of complexity to emerge and persist long enough to become aware, long enough to look up and ask what is happening here. That is not a footnote. That is the central mystery underneath every other mystery. Now consider the timing, not philosophically, literally. The universe is approximately 13.8 billion years old. For the first several hundred million years, there were no stars, just hydrogen and helium slowly gathering under gravity. The first stars formed, burned, and exploded. Those explosions seeded space with heavier elements, carbon, oxygen, nitrogen, the raw materials of chemistry, the raw materials of life. More generations of stars formed and died. Planets coalesced from the debris. On at least one of those planets in a particular region of a particular galaxy, the chemistry got complicated enough, the conditions stable enough, the time long enough, that something that could reproduce emerged, then something that could feel, then something that could think, then something that could do physics. From the beginning of the universe to the first human asking a question about it took 13.8 billion years. That sounds long, but here is the other side of that number. The universe has a projected future of somewhere between 1 and 100 trillion years before the last stars burn out. After that, a vast, cold, dark era of black holes slowly evaporating over timescales so enormous that the entire age of the universe to this point would be a rounding error. And after even that, the heat death, final stillness, featureless, eternal. In that context, the era of stars, the era when the universe is bright, when planets are warm, when life is possible, is not the main event. It is the opening act, a brief energetic phase before the long cold dark. And we are alive right now, in the middle of that opening act. We are, in cosmic terms, at the very beginning. Whatever is aware in the universe in the far future will look back at this era the way we look back at the first moments after the Big Bang, as a distant, almost incomprehensible origin. Feynman felt the weight of this not as depression, but as urgency, as a kind of electric responsibility that comes from understanding your actual position in the story. He talked about science as a candle in the dark, a small fragile flame held up against an enormous darkness that has no obligation to be understandable, and yet miraculously often is. He knew the candle would eventually go out. He thought that was all the more reason to look as carefully as possible at what it illuminated while it burned. There is a concept in physics called the anthropic principle. The basic observation at its core is this: the fact that we exist to observe the universe places constraints on what kind of universe we can observe. We can only find ourselves in a universe where conditions allow observers to exist. The laws of physics contain certain constants, numbers governing how strong gravity is, how fast light moves, how particles interact. If those constants were even slightly different, atoms would not form, stars would not ignite, complex chemistry would be impossible, life would not exist, and no one would be here asking why. We observe a universe capable of complexity, not because someone designed it that way, but because a universe incapable of complexity would produce no one to notice. The observation selects for the observable. That argument does not explain everything. It does not tell you why this universe exists rather than nothing. But it tells you something important. Consciousness is not a passenger in the universe, watching the show from outside. Consciousness is part of the system. The universe is, in some precise sense, looking at itself through us. The atoms in your eyes were forged in dying stars. The brain processing what those atoms detect was assembled by 4 billion years of biological evolution. The awareness experiencing the result is the universe's own material, organized just precisely enough to examine the process that created it. That loop, the universe building something that then examines the universe, is not an accident worth dismissing. It is the central fact of your existence. Most of us walk through life with an implicit sense that we are at the center of things. Our problems in the foreground, the universe as background, a stage. Feynman's deepest insight was the recognition that this framing is exactly backwards. You are not the foreground with the universe as background. You are the universe in the foreground. You are what the background looks like when it gets organized enough to notice itself. Once that inversion genuinely settles, not as a description you use at dinner, but as how you actually understand your position, everything changes. The fact that your time is limited changes. The fact that you will die changes. All of it becomes differently weighted. Feynman talked about death without flinching. He said near the end of his life that what frightened him was not dying. What frightened him was not living fully while he was here. He meant something specific. He did not mean traveling or checking items off a list. He meant paying attention, actually looking at what is in front of you and taking it seriously, letting yourself be stopped by genuine wonder rather than moving past it toward the comfort of an easy answer. That is harder than it sounds. Wonder is uncomfortable. It requires holding the open question without filling it. Most of us are not trained for that. We are trained for answers, for conclusions, for the satisfying click of a mystery solved. Feynman thought that click came too early. Most of the time, he thought people called something understood when they had only given it a name. You can know the name of a bird in every language and still know nothing about the bird. You can say the word consciousness 1,000 times without moving a single inch toward understanding it. Consider what that means for the way we teach science. In most schools, science is presented as a collection of settled facts. Memorize the periodic table, learn the formula, pass the test. The impression it leaves is that the work is mostly done, that the big questions have been answered, and what remains is detail. That is one of the most damaging ideas we hand to young minds, because the truth is the opposite. The big questions are not answered. The detail we have accumulated is staggering and beautiful and hard won. But the foundations, the deepest why, underneath all of it, remain wide open. We have built an enormous, intricate, breathtakingly precise structure of knowledge, and it sits on questions we cannot yet answer. That is not a failure. That is the actual condition of human understanding, and pretending otherwise does not protect anyone. It just produces people who think they understand more than they do. Feynman was allergic to that pretense. He had a particular disdain for what he called knowing the name of something without knowing the thing. A child asks why the sky is blue and is told because of the way light scatters. That sounds like an answer. It has the shape of an answer, but it immediately opens into deeper questions. Why does light scatter that way? What is light made of? What is it doing when it is not being observed? Why does observation matter at all? Every real answer is a door into a larger room. The people who stop at the name of the door and never open it are not wrong exactly. They are just not curious enough. And curiosity, Feynman believed, was not a personality trait you either had or did not have. It was a discipline, a choice, a refusal to be satisfied with the surface of things when the depth was available and waiting. We are in that position right now collectively. We have mapped the genome. We have built particle accelerators that smash protons together at nearly the speed of light. We have sent machines to the edge of the solar system. We have made more progress understanding physical reality in the last 400 years than in all of human history before that. And we still do not know why there is something rather than nothing. We still do not know how matter becomes mind. We still do not know whether the laws of physics are the only possible laws or one set selected from an infinite landscape of possibilities. These are not minor gaps. These are the questions that, if answered, would change everything else. You are alive during the most scientifically productive period in human history. You have access to more understanding of physical reality than any human before you, and at the same time the deepest questions are still open. The most important work is still undone. The candle is still burning, and the darkness is still enormous. That is not a reason for despair. That is an extraordinary position to occupy. You are not living in the aftermath of discovery. You are living inside it. Here is what Feynman would say to you right now if he could. Not as comfort, as a direct, undecorated statement of fact. The universe is not obligated to make sense to you. It is not arranged for your convenience. It does not care whether its laws are intuitive, or its timescales are comprehensible, or its implications are comfortable. It simply is what it is, operating by rules it has never explained to anyone. And yet, here is the part that mattered most to him. When you sit down and do the work, when you actually press against the edge of what is known and push carefully into what is not, the universe pushes back in ways that are coherent, in ways that have structure, in ways that a disciplined mind can follow and sometimes briefly grasp. That is not nothing. That is not something you can take for granted. That responsiveness, that willingness of physical reality to yield to careful thought is itself a mystery worth spending a life on. The second law of thermodynamics is always winning. The entropy account is always increasing. The arrow of time points one direction and never loops back. Everything that has ever organized itself, every star, every cell, every civilization, every mind is a temporary structure in a universe moving toward its final unorganized state. That is true. It is cold. It is precise. It is not negotiable. And inside that truth, right now in this window that physics opened and will eventually close, there are minds that know this, minds that understand the second law and feel its weight, minds that know they are temporary and find that not paralyzing but clarifying, that know they are the universe looking at itself and find that not alienating but intimate, that know the candle will go out and decide, because of that, to look as carefully and honestly as possible at everything the light touches while it still burns. That is what Feynman was. That is what science at its best is. That is what you are capable of being if you take the question seriously, if you hold the open questions open, if you resist filling the space with comfortable answers before the hard ones have been honestly attempted. The universe gave life just enough time to wonder. It did not promise more. It built the conditions for consciousness briefly, in a narrow window of stellar warmth and chemical complexity, and something woke up in that window and started asking why. That asking is the most remarkable thing to happen in 14 billion years of physical history. It is also, by every account physics can give, temporary. What you do with the time between waking up and the window closing, physics cannot answer that. That is the question physics leaves entirely for you. And the fact that you are still here, still thinking about it, that is not nothing. That is the universe. Through you, refusing to stop wondering for just a little while longer,